Coming up on this week's episode of TechSNAP, attackers can defeat an RSA security token in as little as 15 minutes. We'll tell you how. The FBI brought down an online fraud ring, and we've got the details, plus the software update that brought a bank down for days. You won't believe this one. Plus, we've got some great questions and our answers from the audience. All that and more in this week's episode of TechSNAP. Everyone, and welcome to TechSNAP. This is episode 64 of Jupiter Broadcasting's weekly systems network and administration podcast. We recorded this episode live on June 28th, 2012. This is episode 64, and it's brought to you by GoDaddy.com, and the live stream is powered by the incredible ScaleEngine.com. My name is Chris, and joining us every week is our host, the admin, the tech, and the teacher, Alan Jude. Hey there, Alan.
Hey, Chris, everybody. Thanks for watching.
Hey, man. Welcome to episode 64 of the TechSNAP. Yes. And it's been an interesting week out there. Now, one of the things we're actually not covering very much in this episode is Google I/O, although that's been big. It's been in the news this week. But I
haven't had a chance to look at much of it.
And
I
watched
a little bit of a keynote about Jelly Bean or whatever, and that was about it.
So the Jelly Bean stuff was interesting. Did you happen to catch like the whole parachuting stunt that they pulled and all that kind of stuff?
No, all I saw was they used a high-speed camera to show the difference between 4.0 and 4.1 for like loading apps and so on, and the way the animations work. Their Project Butter demo video they rolled. Yeah. That was about all I had time to watch.
They showed off the Google Glasses experiment by having somebody, actually having a crew of 5 people jump out wearing Google Glasses. And then in a 5-person hangout, they skydived down to the top of the Moscone Center, and then they got on bikes, or different people got on bikes, and they jumped rooftops, and then they scaled the side of the building onto bikes, and then they came in through the center, down the hallways on bikes, and presented Sergey from Google with some glasses. Anyways, we covered a lot of the hijinks in FOSHO 96 this week, I/O keynote highlights episode that. Also, we showed the Butter stuff and the new Nexus Q that was announced. And then also next week on Coda Radio in episode 4, we'll be covering how the I/O stuff applies to developers, like some of the new Android stuff. They announced a new PDK, which is hopefully going to keep Android phone vendors in line with Android updates a little better and things like that. We'll be talking about that in Coda Radio, and you can check out last night's FOSHO if you want to see some of the keynote hijinks. But Alan, we have such a big show. We should probably get rolling, don't you think?
Mm-hmm.
All right. So this first story is one of these great ones because it's taken a lot of different turns, and it's also a continuation of something that we've talked a lot, and that's RSA. And now this week, Alan, I've heard everything from the RSA tokens are completely useless now to that's a total exaggeration and everybody just needs to calm down. Things are just fine. What's really going on?
It is a bit of an exaggeration, but it's also an issue.
Okay.
So basically, some researchers have managed to defeat the RSA Secure ID 800 tokens in about 15 minutes. But
Wait,
these are not the tokens like you have for your bank account or your video game where you press a button and it gives out a random number.
Yeah.
These are USB sticks that hold your encryption keys on them.
Oh.
And allow you to use those to log into stuff or to encrypt files or whatever.
So these are tokens more in the more traditional sense.
Right. They're more like the secure token type tokens.
Yeah. Okay.
And but basically what they're doing is what's called a padding oracle attack. So basically, these keys have an API for importing and exporting keys from the card, the token.
Right.
And basically, what they do is the researchers have implemented an old attack called the million messages attack, where they so it's the padding oracle attack is a side channel attack that allows an attacker to see if a message was decrypted successfully or not. So what they do is they take like an encrypted key, something that's already encrypted, and feed it to the token. And the token would decrypt it and whatever.
Okay.
But then they modify the encrypted message somehow. They mangle it.
Yeah.
And then they see whether that still decrypts it or not. And basically by looking at the error messages they get back and how long it takes, they just keep doing that until they've started to get more and more and more information about the actual encrypted message.
Huh.
So by purposely corrupting the encrypted message, or specifically the padding around the message, because of the way block ciphers work, the message has to be basically a multiple of a certain size. So when your message is not that size, you pad the message to make it that size. And basically by playing with the padding a bit, and then watching what the error message is, or some of them don't give an error message, but if they return right away rather than taking the time to actually try to decrypt it, it's because they detected a problem with the padding.
Yeah.
So anyway, it allows the attackers to gain more and more information about the encrypted message until they can actually recover the encrypted message as plain text. So basically, what these researchers have done is devised a more efficient version of the million messages attack. So instead of trying a million versions of the message to figure out what the original was, with their attack, they can do it with only a few tens of thousands of messages in order to
much more
figure
efficient.
out what the encrypted message is.
Very nice.
And then they found that some of the devices have a flaw in the way they implement it, that they can do it with as few as 3,800 messages.
Wow.
Now, one of the things that still makes this a little harder to do is those little crypto keys are so slow that they can only try a couple of messages a second, right?
Oh, yeah, sure. I hadn't thought of that, but that makes sense. They are pretty pokey.
Yeah. So then I have links here to a blog from one of the about it, and then the actual research paper that actually gets into the details of how they did it.
Yeah.
Because most of these keys supports two different methods. There's the RSA asymmetric ciphers. That's your normal public-private key setup. But some of them also do AES symmetric encryption, and there's a different attack against that, also described in the paper. So then RSA posted a rebuttal to the research, saying that don't believe everything you read. The RSA secure token is not cracked, and technically they're right. So basically, RSA contends that the researchers did not crack the RSA secure ID token, but rather they just found a flaw in PKCS #1 version 1.5, which is something that the RSA token implements, but it's not something that RSA invented, right? So it's not their fault. They followed a standard, and the problem is in the standard. However, the researchers show, as you can see in Table 1 on page 9 and Table 3 on page 12 of the research paper, that because of the way the RSA tokens do a very simple padding check, basically because they're very, very underpowered CPUs, instead of checking all the aspects of the message, they just check that it's actually a properly formatted message.
To save time.
So basically, if it has the right header, then it assumes, then it tries to decrypt it. Whereas some of the better devices will actually check, all right, is the padding correct?
Right, the ones that have the
message correct?
The ones that have the CPU horsepower to be able to do that. Right? And isn't this like a hack they came up with because it's
a trade-off for the RSAs to be faster?
Okay.
Right.
You don't think it's just something they did because it's underpowered? Or by today's standards?
They did it so that theirs would be faster, probably.
Yeah. Either way, yeah.
But it doesn't make it any less secure. It just means that it can be broken faster. But if the difference is, in this case, like 13 minutes versus 90 minutes, does that really make a difference?
Well, maybe. Depends. It depends if you. It
probably doesn't make that much of a difference as far as the security, but it does make a difference as far as the usability. So it's maybe a reasonable trade-off.
Yeah.
Doesn't mean that both the 13-minute and 90-minute ones don't need to be fixed, but yeah.
Huh. Boy, RSA's has been having a hard year, haven't they? This has just been one thing after this research paper that we have linked in the show notes. It's one of these PDFs that's pretty interesting, and they sort of break it down here, like Alan was saying, on pages 9 and 10. And
so at the bottom, they have the responses from a bunch of the different hardware manufacturers, and you see some of them are like, all right, we acknowledge this is a problem, and we're going to fix it in the next version of our device. And then some of them are argumentative, like RSA, and say, it's not our fault.
Doesn't need to worry about this. This is just the spec.
Yeah. And they also, in the paper, talk about HSMs, which are hardware security modules. Those we've talked about a bit when we talked about SSL, because most of the certificate authorities use an HSM to store the private key for the certificate authority. And basically, no one has access to that key. They just feed a certificate into it, and the HSM then decrypts the private key, signs the message, and then spits out the final result without anyone ever having access to the actual private key, so it can't be stolen. But basically, the researchers postulate that their attack would work against an HSM as well. And because the HSMs are specifically designed to be really, really fast at doing the crypto,
Yeah.
it would actually make the attacks easier. Basically, even if the HSM does the best type of checking against the padding attack, in the paper it's called FFF, whereas the worst one is called TTT, and then there's a mix of the ones. Even if the HSM did the best one based on the speeds they list in the specs, some of these HSMs could be caused to disclose the encrypted information in as little as 3 hours.
Wow.
Yeah.
That's a real that really puts that whole thing on its head, doesn't it?
Yeah, but basically the researchers weren't able to afford an HSM because the starting price for those is about $30,000 US. And so they don't have one to try it on.
Funny, yeah. Huh, funny. You didn't have that just kicking around, huh?
And
yeah, thoughts.
they also talked a little bit about the tokens that the Estonians use. In Estonia, everyone over the age of 15 has a crypto card that has 2 sets of keys on it. One for digitally signing contracts and government documents and so on, and one that they can use to authenticate over SSL for their online voting system or doing their taxes or whatever. And it can also be used to encrypt email. There's some issues with that. The newer versions that they've been using since late 2011 use a 2048-bit key instead of a 1024-bit key, so they're much stronger. But there's also a problem with a bit of the software they use that they provide. It's a program written in Java that allows the encryption and decryption of documents using the key.
Yeah.
And it has a debug log that exposes the error messages about the decryption, and it basically allows that same side channel attack.
Well, so how could any system that's implemented on a national level like this would not eventually face some sort of issue like this, where it would be this massive undertaking to replace it? I mean, because eventually, even just time moves on, and we'll figure out vulnerabilities in systems that we never expected, kind of like this one. And when it's deployed at a national level, it's supposed to be, a representation. You can say, yes, this is me. I verify this is me.
Right. Well, if you do it similar to something like a driver's license where you replace it every 4 years or so, then you can keep them rolling pretty good. But, if you have to have backwards compatibility at some point, it's like, these cutovers can be pretty hard to do.
Yeah. Huh. All right. Well, of course, links in the show notes. But
it looks like most of the research was about capturing data during the import of a key. So basically starting with something encrypted and keep trying to import it until you can break it. Or until you can get enough side channel information to figure out what the original message was. That's not quite the same as getting the encryption key that's on the device off of the device so that you can decrypt anything that's ever been encrypted with this key. So it's not quite the same, but it's hard to say what some of the implications of this are.
Right.
But it's definitely, makes you think twice about buying these devices.
Well, and a lot of people spend a lot of money on those solutions. Yeah. All right, should we move on to this PayPal story?
Sure.
All right, what's the scoop? PayPal got themselves
this is just a fairly short story, but PayPal started a bug bounty program, so similar to ones that Google or Mozilla or Facebook or anybody have. And basically they're saying if you can find cross-site scripting, cross-site request forgery, SQL injection, or authentication bypass errors at PayPal, they will pay you money.
Good.
Yep. Also, this kind of resolves potential legal ambiguity that researchers were facing, where if you were going to PayPal and trying to forge the cookies and fudge with the results and make malform requests and so on to try to find an exploit like this at PayPal, that could be. You could be accused of trying to get unauthorized access to a protected computer system or something to that effect, where, they would send the FBI after you or whatever. But now that they have this bug bounty program, you can say you're doing legitimate research and, PayPal is paying you to do it.
Right. Right. Now, I see you have a link here to a video.
Yes.
Or
Actually, I
presentation.
don't have a video.
Right, it's a
I thought there was a
presentation.
video. I thought there was a video to go with it of
Right.
the presentation.
Right.
But apparently there isn't.
Okay. But you do have the slides.
Yes.
Crowdsourcing security, huh?
Yes. So at BSDCan 2012, I only saw the last like 1/4 of this presentation because I was writing my exam, which I passed, by the way.
Oh, yeah. Congratulations.
Yes.
That's right. Should tell people which exam you passed.
It was the BSD associate exam. It's basically an exam about FreeBSD, OpenBSD, NetBSD, and DragonflyBSD.
You would never guess by the name.
Yeah.
Well, congratulations.
Yes, my certificate's supposed to come in the mail shortly.
Oh,
so
cool.
I'll hold it up for the camera when it does.
Yeah, there you go.
Anyway, Colin Percival, who was the FreeBSD security officer, although he stepped down about a week after BSDCan to focus full-time on his project, which is TarSNAP. So anyway, he does this presentation talking about how he added bug bounties to TarSNAP and how they work and why he thinks it's working so well.
Interesting.
So in his bug bounties, because the client for TarSNAP, because TarSNAP is a secure backup program, specifically for people that are very paranoid about security and encryption and so on, the client is completely open source. Well, sorry, the code is available, although it's a commercial program, right? So the license is a little specific, but the code is open for anybody to look at and examine, right? Because that's the only way you can trust a program is if you can look at the source code and you compile the version of it that you run. And basically, he offers bug bounties for everything, including style bugs. So if you find just a style bug or something where, like a typo or like a grammatical error in the documentation even, he pays for those. Although some simple things like missing punctuation or whatever only pay $1.
Cool.
Yeah. It was funny, though, during his presentation, somebody found he had put like and something in his, like he had repeated a word during his presentation on the slides, and somebody's like, "Can I have $1?" And he's like, "Yes, see me after the presentation."
Really? Well, I didn't know he went full-time to TarSNAP. So TarSNAP is like the greatest little backup program that I never use.
Yeah. Well, it's kind of specific to a Unix environment, but
yeah. Still though, very cool.
Yes.
Well, it looks like a good presentation. So Alan has a link to the PDF in the show notes.
It's mostly talking about this pyramid that I forget the name of the researcher that described it.
Yeah.
But basically, he was just looking at regular like household accidents, and he found that for every accident there were with like serious injuries, there were like 10 that had minor injuries, and like 6 where there was just a close call, and there's like 600 times when people did unsafe behavior that could have resulted in an accident. And if you want to reduce the number of people getting seriously injured in accidents, you want to reduce the top of the pyramid, or the widest end of the pyramid, which is the people doing unsafe behavior.
Right.
So if you can cut the number of people doing dangerous things in half, then that's probably going to have everything down the pyramid and result in the fewest serious injuries.
Yeah.
And so basically he applied the same concept to auditing source code. And
Very
found,
smart.
If the code looks nicer and is easier to read, people are more likely to read it and more likely to find the bugs.
There you go.
Yeah.
That's a great insight.
It is.
All right, should we talk about this FBI sting operation? Seems like it was a pretty significant operation. I wish we had cool like Fox News swooshy noises for this story. All right, so what's going on?
Yeah. So the FBI ran a sting operation for about 2 years, where they ran a website for carders, which are people that steal and deal in stolen credit cards. And it is now, the operation ended with 26 arrests.
Okay, not bad.
So according to the FBI, through this site and what they managed to intercept, they prevented 400,000 compromised credit cards from being used, which they estimate prevented about $200 million in losses.
Ooh.
Although that number seems slightly inflated.
Yeah.
Because if you look at that, basically, I guess that's maybe not that inflated. If they were able to get $500 out of each credit card, then that would be $200 million. At first, when I saw $200 million, I figured, they just did like, what's the average really high credit limit times the number of cards?
Yeah.
But it seems they might have been a little more reasonable.
Yeah.
The FBI also says that they notified 47 different companies, government entities, and educational institutions about breaches of their network by these carders. So it's like there's 47 data breaches that we never heard about because the FBI intercepted the stolen credit cards before they were used.
Oh, that's interesting, isn't it?
And some of them being government entities and educational institutions is also interesting.
Gosh. Wow. Sometimes what's interesting, sometimes these things are going down and happening, and the FBI kind of either allows it or intercepts it in order as part of the building their larger case, and you just never know.
Well, that's how they managed to arrest a lot of these people. Like I have some examples here. Okay. One of the hackers there, Zero, used hacking tools to steal information from the internal databases of a bank, a hotel, and a bunch of online retailers, and then sold the information to others. Now, the way they caught him was one of the people he sold the data to, who he thought was a fellow carder, was in fact an undercover FBI agent. So basically, they did this thing to catch him red-handed so that they would have, better proof. Another one named Josh the God, who was apparently a member of UG Nazi, which is the group that said they hacked 80-something banks we talked a little bit about a couple weeks ago. He met in Manhattan with an undercover FBI agent to accept delivery of counterfeit credit cards encoded with stolen information. So
he took delivery from the FBI? The FBI gave him credit cards? Okay.
Yes, and then when he went to an ATM to try to withdraw funds from one of them, they arrested him. So, I would get, dude. I might almost fall for that one if somebody's walking up and says, "Yeah, here's a Discover card with $100,000." No, there's like a box of them though. There's like giving them like thousands of. It's like,
okay, I mean, I wouldn't fall for that, but geez, that's harsh though.
Right, but how we talked about. Well, no, but. I mean, they arranged the meeting through this hacking site, right?
It sounds like a dummy
they didn't do it on the street.
Who does that? Who takes credit cards directly and then starts cashing them in like that? That sounds risky in itself. I mean,
well, we talked a bit about how that scheme works with the hack of that other bank, where you would go to the store, buy the $10 gift cards,
right,
and then encode them as credit cards.
That's clever.
The FBI was saying, here's a bunch of fake cards that you can encode with your stolen credit card information. And then when he tried to do that, they arrested him. There was another guy called Cool Plus Cake who was selling stolen CVVs, which are the 3-digit and 4-digit verification numbers on the back of the cards.
Right.
And he was advertising those to fellow carders and said that he could get fresh CVVs on a daily basis from databases he had hacked into that he hacked into them, but he kept his access open so he could just drain cards, new cards that came in every single day.
Oh my gosh.
Now, according to the PCI DSS, which is the Payment Card Industry Data Security Standard, CVVs are not allowed to be stored in a database. That's the entire point of the CVV. Right? So when you run a credit card transaction, you store the credit card number and all the customer's information in a database to run the credit card or whatever. Especially if you're a kind of company that bills a credit card every month, then you need that information to do it every month.
Yeah, okay.
And the point is you never store or write down the CVV value so that if the database is stolen, the hackers don't have the CVV value.
Right.
And then when you go to a store like Amazon or something and try to buy something online, they want that 3-digit number. And if you have a stolen credit card where you don't have that number, you can't use the stolen credit card. That's the entire idea. Except a lot of these companies seem to store those CVV values in their database, which is against the PCI DSS and prevents it makes the CVV a useless value. Because the CVV is actually a 3 or 4-digit numeric hash. It's actually the hash of the credit card data and a bank's secret key. And that's how they verify that hash.
Oh, I didn't know that.
It's actually some interesting crypto. And the whole point is, unless somebody hacked into the bank and got the bank's private key, if they did that, then they could calculate the CVV for every card issued by that bank. But that's why that key is probably stored in a hardware security module.
Yeah, totally. I hope. Okay, let's hope.
There are a bunch of websites that don't require the CVV value, and that's mostly just because they don't bother. A lot of times, if you do have the CVV, your credit card processor will give you a discount on the amount they take from the transaction because there's less chance of fraud. So the CVV is usually only used by places that are trying to prevent a lot more fraud. If it's a transaction where there's not that much chance of fraud, then they don't always require it.
Very, very interesting, Alan.
Yep.
And an interesting little trivia bit about how those codes are generated in the first place. I never knew that. Should we jump over to this next story?
Yes, another banking story.
Yeah, another banking story that almost made me panic and run for the bank and withdraw all my funds. No, I'm just kidding. But maybe if I was in Scotland, right?
Right. This didn't actually affect people's ability to withdraw, but
Okay,
so
good.
there was a botched software update at the Royal Bank of Scotland, which also runs a number of other banks in the UK, including what's this here, NatWest and the Ulster Bank, that basically caused the customers' accounts to be frozen. So customers could withdraw funds, but if they deposited new funds, those didn't show up in their balance.
Huh.
And so, if they got a deposit, they wouldn't be able to withdraw that money. And it caused people some problems, where they wouldn't be able to travel or, even buy groceries in some cases.
Oh.
Because, their automatically deposited paycheck was deposited, but they didn't show up in their balance, so they couldn't withdraw the money.
I want my chicken.
Yeah. So on Monday the 18th, a glitch was introduced into the banking system at RBS that basically prevented new deposits from being credited to a customer's account. Then there's an interesting timeline here at the register.co.uk, the news site. They have stories starting on day 3, which is the one I linked in the top. And then on day 4, they're talking about how it's still not solved and the bank doesn't have an ETA.
Jeez, are you serious?
Yep. And then on the 25th, they came out talking about how the confidence in the bank was slipping because, still hadn't resolved this yet.
Yeah.
And then later that day, details started to emerge about the cause of the problem.
Okay.
Basically, there's a batch processing software that the banks use. And this one, the one they use is called CA-7, which is made by the company CA, which is Computer Associates. And basically, they did an update to that. And sometimes the updates break or don't work properly.
Computer Associates had an update that broke something? No.
No, it was an RBS update to their version of the software. It's
That
not so much
sounds
the software, it's
complicated.
like the configuration or whatever.
Okay.
Or the schedule, because what all this is batch scheduling, right? Banks settle things out overnight every night. They don't actually do everything in real time.
Yeah, I
Still
painfully know.
confuses me why they still do everything in batches like that. But anyway.
I don't know.
So normally it's a fairly standard thing to back out a change and go back to the version they were using before the change. But apparently, the sysadmin botched it. And so as part of that, what happened was, the mishandling of the batch schedule data while backing out an update. So they were undoing the update. And basically what happened is when they did the back out, a major error was made. And basically an inexperienced sysadmin who was backing out the change basically cleared the whole queue and basically erased the entire schedule. So now no transactions were being processed in the batches.
Oh, no.
And basically that caused a disruption of 6.9 million customer accounts.
You think?
And basically made all their deposits not actually show up in their account because the batch never got processed.
Jeez Louise, Alan. Man, as somebody who's worked in bank IT, I know what a nightmare all that batch processing stuff
What
can be.
what a lot of the uproar about the problem is that last year, RBS Bank laid off about 1,000 people from their IT department. And basically, the registrar managed to get confirmation that more than half the team that runs the CA7 batch processing software were outsourced to India. And, it seems that
I'm going to go smack my head against the wall.
Unexperienced person that may have accidentally botched the update and botched the undoing of the update and erased the queue and everything may have actually been somebody that worked for the outsourcing company in India.
No. Impossible. That never happens. That never happens.
And specifically, there's also some talk about how, the system, there's a lot of legacy systems. It's all very complicated and, the integration with all these different old systems and mainframes. Mm-hmm. And that, when they laid off their more senior people that maybe understood how all those systems integrated, and now they're using less experienced people and outsourced people that don't understand all of the intricacies, that, their changes that they make to try to keep things updated or whatever cause these cascading failures.
Oh yeah. Oh yeah. Oh yeah. It's a wild web of all interconnected systems that don't really play well together, and sometimes don't even really speak even the same types of languages. I mean, it's just crazy.
Yes, some of them are really old mainframe systems.
Yeah. All right. Well, any other thoughts on that one?
Not much. Just that it makes you wonder how easy that could happen at any other bank.
Easy. It probably does happen, and we just, they just, oh, come on, we get in there, somebody gets in there, and they get it running overnight, and we don't even know.
Yeah.
All right. Well, why don't we hit pause right here and say thank you to GoDaddy.com for sponsoring this week's episode of TechSNAP. Now, I did something cool this week. I went over to GoDaddy.com, and I registered jblive.fm. Yeah, jblive.fm, and I used the code TechSNAP10 when I checked out to save 10% off my order. And now, if you type into anything that supports an IceCast stream, just do http://jblive.fm. It tunes in our audio stream immediately. You can type that into VLC, or in most mobile devices, your mobile browser actually just supports streaming right in the browser, so you just put that in the URL bar. It's super cool, and GoDaddy makes it really crazy easy. And we have a very special offer that ends in just a few days. By the end of this weekend, the $1.99 3-month hosting that GoDaddy's offering. I mean, come on, are you kidding me? Get this, $1.99 for 10 gigabytes of space, unlimited bandwidth, 100 email accounts, and 10 MySQL databases for $1.99. That's crazy.
It is.
If you use our special checkout code, are you ready for this, ladies and gentlemen? 199 Tech. When you check out, you can get $1.99 economy hosting. That is great for the summer if you have a project you want to throw on there, if something you're just checking out that you're not even sure how successful it's going to be. Or if it's something you're kind of building and you want to have a place to dump web files on or something to work on, and then if it gets more popular, you just go check a few boxes and you just automatically go up to the next step, where then you start to get all kinds of extra things. So check it out for $1.99 hosting for 3 months, $1.99 Tech. Or if you just want to save 10% when you check out, you use our code TechSNAP10. And thank you to GoDaddy for supporting the TechSNAP show.
Yep.
All right, Alan. Well, that's our top of the show. I think that means it's time for the TechSNAP feedback. Thanks for sending your emails to techsnap@jupiterbroadcasting.com or using the Contact Us form over at jupiterbroadcasting.com/contact. Alan, we have 2 questions this week. Are you ready for the first one, sir?
Yep.
All right. It comes from Alex, and Alex writes, "Hi, Alan and Chris." Hey, Alex. Your show is quite inspirational. Someone like me who is coming from knowing nothing about servers and diving into sysadmin realm. Well, thank you, sir. He goes on to say, Alan, I'm in the process of setting up a more redundant hosting system for my sites, some PHP, some Ruby on Rails, and I've run into a wall. I have a basic structure planned out, a load balancer controlling a bunch of the Apache servers, and a MySQL server, pretty basic layout. But I'm not sure how to sync my document routes. For example, if I have a WordPress site and I do a plugin upgrade from within WordPress, how do I make sure those changed files are then mirrored across all of the HTTP servers? Also, if I upload files through SFTP, where would I upload them to? And how would I ensure they are all replicated across all of my servers? Or is there a better method for simply replicating files across all the servers? I've been thinking possibly a NAS server with just some Samba on it or something. What would you recommend? It's worth mentioning I'm using Rackspace Cloud servers running Debian to accomplish this. Thanks, Alex. Very
So those are
interesting
basically virtual machines.
Yeah. What do you think, Alan?
There's a couple different ways. You basically can decide one server is the master copy of the files and then export to the other servers via something like NFS. Mm-hmm. And then that NFS can be writable so that maybe any of the web servers can take like an image upload when you're making a new post and so on.
Sure.
You can have a dedicated NAS or something that's doing the storage, and then all 3 of them are mounting that. Again, that would be something like NFS or Samba. You can't really do something like iSCSI there because you can only have that mounted on one device at a time.
Well, now, Rackspace Cloud Hosting has like a whole like disk storage system you can use.
Files.
Yeah.
But that's something that's more like S3, and it's meant for long-term storage more than constant access.
Okay. Because, I think a centralized storage is...
There's like an API to put a file in there, but it's not really... It's not a file system.
God, don't you think it seems like Rackspace would have some sort of solution for this? Because it basically, he needs like a central. He needs like a NAS, like running NFS or something. I don't know about Samba. I don't know about Samba for something like this.
But no, NFS will be better, and it'll have the native users and so on.
Yeah, exactly. That would be what I would do, is try to have the same user IDs, so same UIDs across all the hosts. But
for some, you can use something like NIS so that you're actually doing that, and that's partly how the Scale Engine's web cluster works. Is we use the NIS/Yellow Pages to have the users exist on every machine, including in the jails, which is more complicated, but beside the point.
Okay,
and
interesting.
And we have the NFS mounts to our RAID server.
So that probably even works at a customer level, doesn't it? So when I log in, I know some of the depending on what I'm interacting with, I'm totally talking to different hosts, but I'm using similar IDs, I think.
It's basically a single sign-on.
Yeah, okay.
You have one SSH username and password that actually works on 10 different
But if you were talking like 3 servers, you could just grab the Etsy password and Etsy shadow file and call it good. And,
Although, because I'm doing 10 servers, I set up an NIS thing.
I'm surprised Rackspace doesn't have a more elegant...
The advantage to something like NIS is when you log in and change your password, it's updated on all the machines automatically.
Yeah, that's for sure. It's definitely an advantage.
But this is kind of something that the cloud lacks. Like, you have things like S3 and Rackspace Cloud files, but they're not really a file system.
Right.
And then, there's things on Amazon like the Elastic Block Store, but you can only have that attached to one machine at a time.
Right, and they're actually more intended for like API type access, where you're actually accessing the storage worth of
an API, yes. And then the Elastic Block Store is basically an alternative to iSCSI, and that's a physical. You're emulating a physical disk, so that can only be attached to one machine at a time.
Yeah,
and so basically you need almost some kind of. We've talked a little bit about distributed file systems like Andrew and CUDA and
DRDB.
Yeah, and some of the more block-based ones like Hast. And
what about
block-based too?
What about going a different route? What about going more like proxy servers up front that serve up the web pages and handle
you can do something like reverse proxy, like Varnish or something that caches, and then reduce the number of queries that are actually hitting your Apache, so you only need one Apache server.
Exactly. What about that?
It depends on your load. With WordPress, you can get away with that, depending on if people are logged in, how many pages there are, how often they're updated, and so on.
This is the kind of thing that Scale Engine kind of takes care of, because you guys can take care of the storage backend and the caching front end.
Yep. And then another thing that lost my point. I had one.
Along the lines of reverse proxy and
not quite.
Something with Nginx. Maybe put Nginx servers in front of that Apache host.
There was
servers. What you need to do is put a FreeBSD box in front of that Linux box.
Depending on what you're doing, the more simple solution for their system there would be have one of your Apache nodes dedicated as the one for writes. So anytime a request is a post, like somebody's posting, an HTTP post, but that'd be when somebody's sending a comment or making a new post or uploading a file, those would always go to one specific node, which would be the one that has the authoritative copy of your files, and would be the one where you say install plugins. And then your other nodes, you could just use rsync to push the changes to the other nodes.
Yep.
Now, if you're using rsync, there's an advantage to doing a pull style instead of a push, though. Right. So if you have your master host and it pushes out the changes, say every 10 minutes to the other servers, if that one then goes down for, say, a while due to a hardware problem, that's less likely when you're using virtual machines and they're on redundant storage and so on.
Yeah.
But if you're using physical machines, if that machine goes down for whatever reason, and you switch one of the others to be the master, and you start pushing up from that one instead.
When the old one
comes back up, if it overwrites your files with older, then you have a problem.
That would suck.
That's why you're always pulling. Then if one goes down and then when it comes back up, it pulls, it's not a big deal.
Great point.
And so that way, when the old master comes back up, it doesn't try to resume its role as the master.
Yeah. I would be tempted to say, and I think he knows it, centralized storage. Simple front end servers with a load balancer.
With rsync if it's just a WordPress blog.
Yeah.
But if your site's big enough that you're going to need multiple servers like this, it's likely you're going to want something more centralized and distributed.
And maybe question if it's worth rolling that yourself, or if maybe that's something that's worth hosting somewhere else, or I mean, if it's WordPress, even consider WordPress.com. They have extremely cheap hosting options for WordPress sites. They're a little limited in what you can do. So, I mean, it depends on what your functionality is. But
right. But, there's things like Scale Engine that are designed to take a WordPress blog and scale it out across multiple machines and take care of the problems of integrating the storage and even scaling out the database, which is a different complication.
Now, this next email comes from the Middle East, so I'm not sure if I'm going to get the pronunciation of the name right. But are you ready to go to this question?
Sure.
All right. It comes from, I'm going to say, I'll say lol. Maybe, so you got to give me, you guys got to help me out sometimes. So I'm going to say lol. It's LAWAL. Lol. Yeah. Okay. Right. Lol. Kind of like.
Lol.
I'm not sure. Yeah. It says, could you explain clearly how VPN technology actually works? I can't actually wrap my head around how your local machine is tricked into having some foreign IP. I can understand if my IP address is 77.2.2.11. A VPN conx will grant me a remote local IP, say 10.0.3.1, from, say, the company headquarters. But how does that VPN server and client achieve this? And what happens if there's also a 10.0.3.1 in my local internet zone? Will all of the IP traffic be directed through the VPN infrastructure? Thanks for the great show, and thanks, Alan, for all the jewels. So I think what he's probably asking is how does VPN IP assignment and routing work?
And then he also had the problem with the IP conflicts. Okay, so a VPN, a virtual private network, works on what's called encapsulation. So the way that data works on the internet, if you don't know, there's this 7-layer model called the OSI model.
And the top layer is guacamole.
No. So basically, the way everything works on this is at the top of the model is you have your application data. So this is the message you're trying to send. So right now in our Skype call, that message is this video stream. Or on IRC, it's the message that I just typed.
Right.
So that's the application data. Then that gets wrapped up in a bunch of different layers. Like there's a presentation layer where things like SSL happen. And then you get down to TCP, where the message gets broken up into nice sized chunks and send out, and we make sure that people receive them in the same order that they were sent in. Mm-hmm. And then you have things like IP, which takes care of routing around the world, and so on and so on. And it gets down to the physical layer where you're actually sending electrical pulses or light pulses over a cable. So with a VPN, what you actually do is you have more encapsulation. There are basically 2 or 3 types of VPN. There's layer 2 VPN and layer 3 VPN.
Yeah.
So basically, with your regular layer 3 VPN, you send an IP packet that actually inside of it, in the application data, actually contains another whole packet. So basically what happens is, if I'm on my computer here and I connect to my VPN that I have, what happens is I run, in this case, OpenVPN, which actually uses layer 7, but beside the point. It creates a virtual interface on my computer that looks like a network card, but actually isn't. It's just software. And any data I send to there then goes to the OpenVPN program, which wraps it up in a regular internet packet, and in OpenVPN's case, encrypts it with SSL. And it sends it over the regular internet to the other end of the VPN.
Right.
In this case, the VPN server, where then they unwrap that packet and get back the packet I'm actually trying to send. Mm-hmm. So basically, a virtual private network literally runs a virtual cable over the internet to the other location, and normally encrypts the packets as they're sent.
Right.
So that people can't see what's inside of them.
Yeah.
So basically, it uses the routed internet to send data between 2 points as if they were on the same LAN or on a WAN. So does that make enough sense?
Yeah. No, that's great. In fact,
basically, it takes the message, wraps it up, and sends it to the other side where they then unwrap it.
Right. And the way that sending happens is just based on your standard TCP/IP routing table, because that IP address gets assigned to that virtual adapter. And when
so I'll get to the routing table thing in a second.
Oh, okay.
And so the server on the other side, when you connect, usually uses something like DHCP or a static assignment to give you an IP address on the VPN, which is normally an extension of the LAN on the far side.
Uh-huh.
So like if it's at your company's office, they have a big LAN and they have a pool of IP addresses on the DHCP server that are given out to the VPN clients. Mm-hmm. And so then you'll get that IP on the virtual adapter on your machine. Mm-hmm. And when you do, you'll also get a subnet mask. And that defines basically the subnet of the VPN. And in your routing table on Windows or Linux or whatever, it'll say to get to this subnet, route it via the VPN to the gateway on the other end of the VPN. So instead of the router being, your little, Netgear or Cisco box at your house, it's actually the VPN server at the other end of the connection. And so whenever you want to send packets to the VPN, that any IPs in that range, whenever you send a packet to any IP in the range of the VPN, it goes across the VPN link and goes to the other side. Mm-hmm. Now, if you happen to use the same subnet on your end, that can cause a problem. And the way your computers select which route in the routing table to use is they use the most specific one. So if you have routes for like 10.0.0.0/8, so for anything that starts with 10 is over your local LAN, and then you have a VPN that says only 10.0.3. something, only that block of 256 IPs goes over the VPN, then that block of IPs will go over the VPN and everything else in that bigger range will go over your regular LAN. But if it's vice versa, if the VPN is wider than your LAN, then it can cause packets to go over your LAN instead of the VPN. And that's why most VPNs will try to use a range that most people aren't going to be using at home. Right, that's why you don't see most VPNs don't use 192.168.0.
Right, as long as the people that set it up are thinking ahead. I can't tell you how many clients I've had where they have office locations or like home office locations where they VPN back into the main office, and their IT guy set it up so just all of their internet traffic goes over the VPN back to the central office, and all of their browsing's done through that, and they have no idea that it's like that. So even like on the weekends and stuff, they're just browsing the internet at home, and it's all going through their Works VPN.
Yep. Right, that's another thing is depending on your VPN client, it may by default automatically set your default route to be the VPN.
Yeah.
Now, for example, if you're a business person and you're traveling, you're at a hotel on the free Wi-Fi, you probably want all your traffic to go over the VPN.
That might make sense. Yeah.
But if you're only trying to access files off a file server or something, you may only want that one subnet to go over the VPN.
Giant robot Q in the chat room says that's how he saw his boss's censored, it says in the chat room, browsing habits. He got him busted just because of that same thing. Yeah. So I guess that's a good lead into how the routing works. So
yeah, basically, depending on the configuration of your VPN, you may route all traffic over the VPN or only a certain subnet. And if it's only a certain subnet, you want to make sure it doesn't conflict with whatever subnets you have on your local interfaces. Because I have something like that. Like I use a certain 10 dot subnet for myself at home, and then my server's VPN uses a slightly different subnet, and so they're near each other but not overlapping.
I find that for me personally, usually a reverse SSH tunnel kind of a thing is, for what I generally need is enough right there. I don't really need to go through VPN.
I have one virtual machine that's entirely wrapped via VPN that I use for Netflix, so it looks like I live in the States.
Very smart. Nice. Nice. Of course, now hopefully nobody at Netflix is watching. There's been times where it's just nice because the thing about a VPN is the applications on your machine really kind of just think they're on the other physical LAN. And so, a lot of the things like local network instant messaging can work depending on what the rules are on the firewall for the VPN. So it could be kind of a nice way to really be integrated.
It depends on the VPN whether broadcasts go across or not.
Yeah.
And that can affect whether games work or not.
Yeah.
Because I've used a VPN before to play a game, like a game that only works over LAN, over the internet.
Yep. Yeah, there's a few old games, in fact, that's a good way to do that. All right, sir. Willie, other thoughts on that one?
Because, actually, the game we were playing was like the very first Half-Life or whatever, and it only did like IPX. It didn't actually do TCP/IP or something like that.
That was a trick, too, you could use back in the day to get some old Xbox games the old Xbox that only did local LAN play. That was another way you could do that, but, of course, that didn't work very well. So. All right, Alan, with all those questions done, that means it's time for the TechSNAP Roundup. And welcome to the TechSNAP Roundup. Yeah, that's what that crazy music means. Now, the Roundup are the stories that didn't quite make it to the top of the show. but we still want to talk about them and maybe give you some links to follow up on your own after the show. And they're almost always exclusively powered by our subreddit over at links.techsnap.tv. Alan, are you ready for the first story from the roundup, sir? Now, this one's pretty interesting for any Plesk users out there. It looks like it's been discovered that Plesk stores passwords in plain text, or at least it used to.
Yep. So
I guess we should make the disclaimer that version 11 has been released and it doesn't store them in plain text.
Right. But basically what happened was, after the LinkedIn hack, and there was a lot of talk about, don't use just a plain MD5 or SSH1 hash to store your passwords. Mm-hmm. It's like there are some things that still store your password in plain text, which is really bad. Mm-hmm. And as I've actually talked to a bunch of people in the chat room about this, but one person found that when he requested a password reset from his ISP, they sent him his original password in plain text.
Yeah.
Right. If when you request a password reset, if the site tells you your old password instead of just generating you a new random one, it means they were storing your password in plain text somewhere for them to be able to know your password.
That's bad.
If they were using proper hashing, they don't know what your password is.
That makes Alan angry.
Yeah. And so I've seen this a lot of other places. One was a fancy affiliate customer management system, and you answered the secret question, and then it just popped up your password on the website.
Very user-friendly.
You're storing the password in plain text? That's horrible.
That makes it real easy, so that way they don't have to call their support department and cost them money.
Right. But, it could have just reset the password without requiring anybody in support.
I know,
but
that's
they
the
disclosed the original password. So not only did I, it was something I was doing for a customer, and they changed the password, and I managed to find out their new password. And they probably didn't want me to.
Oh, wow.
And so And basically, it's become quite a common practice for hosting providers to do that. And basically, naming and shaming is the only way that'll ever be changed.
Snap.
And so Plesk, which is a control panel like cPanel or DirectAdmin or whatever for web hosting companies, which was bought by Parallels a number of years ago, is used on more than 250,000 Windows and Linux servers. And basically, up until version... everything before version 11 stored passwords in plain text.
Yeah.
Version 11 didn't come out until 2 weeks ago.
Yeah.
And there are a lot of servers still running really old versions, as far back as Plesk 8, which came out in 2006.
Yeah. So that means upgrade. Contact your web provider.
Yeah. Basically, if you run your own server that has Plesk, then you need to get that upgraded to 11. And I'm not sure how the process actually deals with the passwords that are already in there. Does it keep those in plain text until the person changes their password, or what?
Don't know how. Don't know.
But yeah, so basically there's probably somewhere around 250,000 servers that had stored the passwords in plain text. And some of those probably had hundreds of customers.
So, all right, Alan. Well, interesting enough, we wanted to get the word out there. Should we move on to the next story in the roundup?
Yep.
All right, so this one I don't think is going to be too surprising, but here we go. So Zone Alarm has conducted a survey and says that security savvy varies with age, and experience also counts. So Zone Alarm polled 1,205 young and older tech users from the United States, Canada, the United Kingdom, Germany, Australia, and so on to find generational differences in attitudes towards computer security. About 40% of the participants were between 18 and 35 years old, and about 20% were between 56 and 65. Okay? And then also there was some older people in there too. Here's what they found. The survey found that respondents aged 18 to 25 generally tended to overestimate their knowledge about computer security and spend less than other age groups on security products. And also what I thought was interesting is do less than, say, like the baby boomers to protect themselves online. I actually kind of would have thought it would have been the other way around, but the baby boomers essentially are more paranoid.
They're the ones that, they hear about all the nasty things, and their solution is buy a virus scanner.
And they have more Nest Egg. They have more Nest Egg to protect.
Yeah, and, they're buying things like Zone Alarm. One thing they found is that, 63% of 18 to 25-year-olds profess to being knowledgeable about security issues.
Yeah.
It's like, I'm sure that the number of people that are actually knowledgeable about the security issues is closer to like 13%, not 63%.
Yeah. What it really is.
However, basically of those same people, more than 50% admitted that they had gotten a virus before. So they're not that knowledgeable about security.
Yeah. What I really think this is Zone Alarm figuring out what demographics that antivirus manufacturers need to target.
And firewalls and so on.
Yeah, exactly. All right. Well, I want everybody's blood to boil just a little bit here because we've talked about SOPA, we've talked about PIPA, and we've talked about ACTA. And in fact, ACTA looked like it was getting its ass kicked over in the EU for quite a while. But recently, about 6 days ago, TechDirt ran this story that really has me concerned. EU Commissioner reveals he will simply ignore any rejection of ACTA by the European Parliament next week. And this is a quote from the commissioner. If you decide for a negative vote before the European Court rules, let me tell you that the Commission will nonetheless continue to pursue the current proceedings before the court, as we are entitled to do. A negative vote will not stop proceedings before the Court of Justice. So regardless of how the vote goes, they want to continue ahead with ACTA. The courts plan to continue ahead. And remember, this is a trade agreement, so it's a little different of a process.
Right. The court has something specific they're looking at with it, though, don't they? Like I don't know about some of the way the things are set up over there.
Yeah, I know.
As far as what authorities he has to do that and so on. But.
Yeah. They say they want to discuss and identify possible clarifications that can be made. That might be what you're talking about.
But when there's a court involved, it seems a little more specific.
Yeah. All right. Well, let's just keep watching that. But gosh. Man, between that and there's also the Pacific trade agreement that's going on right now, it's never going to end. All right, well, here's a story out of Slashdot that I think you flagged, Alan. Australian telco causes minor panic while preparing its new web filter.
So basically what they were doing is watching regular traffic and basically replicating everybody's requests through a server in Chicago. So whenever a user went to a site, their server in Chicago would also go to make the same request. So they were basically building up, they're like simulating them proxying everybody's requests and to decide what to filter or whatever.
So they're like, we're going to filter based on what you're actually going to, those jerks. And what's so creepy about it is this Australian ISP sends it to a Chicago company.
Right. Maybe just a cheap place for them to rent a server or something to test it with. But
maybe
it seems all kinds of hinky. But yeah, the Australians are specifically worried about, basically their traffic being mirrored to somewhere where the U.S. government can have access to it.
So it's going to be an opt-in web filter, it says.
Yeah, so apparently, customers can opt in to have a porn block or something. I don't know exactly what the point is, and it seems awfully hinky to me.
Yeah, interesting. Well, of course, links in the show notes if people want to read up on that. And if we have any viewers and listeners who have a little idea what's going on and you're down in that neck of the woods, we'd love to hear from you. So email us, techsnap@jupiterbroadcasting.com. All right, Alan, well, I think that brings us to the end of this week's episode.
Yep.
Now, of course, TechSNAP is live Thursdays at 1 p.m. Pacific over at jblive.tv or jblive.am. And that is what time Eastern, Alan?
4 p.m. Eastern, 2000 UTC.
There you go. And of course, then TechSnap's generally out for download a few hours after that. And if you stop by the live stream, you can always hang around and catch Unfilter. Unfilter's at 7 p.m. Pacific and then is out for download Saturday mornings. All right, Alan. Well, great show, sir.
Mm-hmm.
Thank you very much. And thank you, everyone, for tuning into this week's episode of TechSNAP. And we'll see you right back here next week.